Okay, so this side is where we're starting. This was Thursday's lesson. So function operations. The nice thing about function operations is truthfully, other than one thing, you guys know how to do everything. It's presented in a different way, but like skill wise, you guys knew how to do everything except for there was one new thing. Reminder about function notation. What is f of x, g of x, m of x, all of that the same as? Y. It's just a different way to name it so that I can say like your K equation and you guys actually know what I'm talking about. One thing to point out here, this x right here, why do they all have an x underneath or in there? What is x? The variable. So that x is just in there to say they're using a variable of x. It doesn't mean we're timesing by x or anything like that. So in function notation, what operation are we being asked to do for this first one?
Well,
add them together. That's it. F plus h. This x right here is the same as up there, where that just means that's our variable. So that parenthesis x afterwards literally just means x is our variable. It doesn't mean anything timesing by x. We take our f equation, which is 3x squared plus 2, plus our h equation, x squared minus 25. That's it. F plus h. When we combine like terms, how many x squareds are we going to have?
4.
And then what will our constant be?
-23.
So f plus h of x, literally take your f plus your h. That x at the end just means that's our variable. The next one. Now the m and the g are touching. So what operation does that mean? Multiply. Same thing right here. This right there just means that's our variable. In function notation, that parenthesis x at the end just means we're using a variable of x. M is 2 root x times g, which is negative 5x. And then the thing about the reason we're doing it now is you guys have learned a lot of stuff this year. So just looking at that, can the two x's multiply together? Why not?
One's on completely different side.
Yeah, one's inside, one's outside. So with radicals, the outside stuff can multiply together. So outside the radical, what is 2 times negative 5x?
-10 x.
And then what's still inside the radical?
Square root of x.
Yeah, that's it. Inside multiply together, outside multiply together. Okay, next one. What operation are we being asked to do? Subtraction. So we take our K equation minus our G equation. What does G equal? And then this one has something new right here. Now there's a 2 there instead of an x. So what are we going to do with that 2?
That's going to be our variable.
Yeah, we just plug in a 2. It's going to replace our x. So when you have something in those parentheses, that's saying your variable spot. So if it's an x in there, x is your variable. If it's a number in there, it's not saying times 2. You're just going to plug in a 2. Because just like here, x was our variable. Now it's saying put a 2 in that variable spot. When you plug it in, I like to plug in right away just because we're better at doing math with numbers rather than with variables. So if you know you're plugging in a number, you don't need to simplify, just plug in right away. Because what's 2 times 5? Or 2 plus 5? What's negative 5 times 2? What's 7 minus negative 10? Positive 17. 2 negatives make positive. So operationally, you guys know how to add, you know how to subtract, you know how to multiply. It's just written to you in a different way. The main thing is you just have to recognize what the steps actually mean and go from there. Next one. What operation are we being asked to do? Multiplication. H, M, they're touching, that always means multiply. What does H equal? What does m equal?
2.
Yeah. And then the fact that there's a 16 in these parentheses, what does that 16 mean?
That x is going to turn into 6.
Yeah, x turns into 16. So when you have something in those parentheses, that just means you're going to plug it in. I personally will always plug in first because numbers are easier to work with than variables. And once you plug that in, it's calculator work, it's just following the rules. 16 squared, either from your yellow sheet or from a calculator. What is 16 squared?
256.
And then on the other side, what's the square root of 16?
4.
Times 2? 8. What's 256 minus 25?
231.
231 times 8. 231 times 8. 1848. So again, math-wise, not tricky. It's just knowing what it means when you see it. If there's a number in the parentheses, you plug it in. If there's just an x in those parentheses, just leave it as an x. It's not saying times x. It's just saying in function notation, x is going to be your variable. Do you guys have any questions on the first 4?
No.
Okay, next one. Put a star next to this one. This is the new thing. This is still in function notation. And then the perk of function notation is like that 16 right there. We knew we had to plug in a 16. So function notation is nice because it tells you what to plug in. This is a different type of operation. Does anybody remember what this is called? Starts with a C. CO. Composition. So a composition is a type of operation. It's a new operation that you guys probably haven't seen yet. But a composition just means like in an equation, you can plug in a number. You can plug in a variable. A composition means what are you plugging in instead? What? Another equation. So a composition just means you plug one equation into another. Compositions themselves aren't tricky as long as you remember the setup. Because once you have it set up, like it's pretty straightforward, you just plug it in. But a composition, you just have to know you plug one equation into another. That's all a composition is. So instead of just like plugging in a 16, we're going to plug in another equation. The way you figure it out, I look at this kind of in an order. So the way you say this is f of g of x. You just go in order. F of g of x. Every parenthesis is an of. And the first equation, f, whatever you're given first, I think of it as like the skeleton. It's the bones. It's what everything's based off of. It is the main equation. So f is given to us first. And we look at f up top, it says 3x squared plus 2. X is your variable. So what f's equation means is 3, whatever I'm supposed to plug in squared plus 2. Like that is all f means. X is your variable. X, anything can be plugged in there. So your first step is you take that first equation and you write it down because it's the skeleton, it's the bones, it's the base of everything. So f's equation is 3, whatever you're being told to plug in, squared plus 2. So do you see how we just took our f equation and instead of an x, what did I put there instead?
You put in one.
Parentheses. So you start with just parentheses. Now you go back. What are we being told to put in those parentheses? G. What is G's equation? That's what a composition is. You start with one equation, and in the variable spot, you're just being told to put a different equation there. So a composition just means you plug one equation into a different one. For me, for right now, If you guys left your answer like that, I would be happy. Because I can see your structure, I can see your starting equation, I can see what you plugged in, I can see your parentheses for your variable spot. Final answer wise though, like ACT, if you take college algebra, pre-calc, anything like that, they will want it simplified. So if you were to fully simplify this, what's negative 5x squared?
Should be 25x.
25x squared, because the negative make a positive. What's 25x squared times 3? Yeah, 75x squared plus 2. So either of these two equations I would count as right. Keep in mind, like ACT-wise, other math classes, other than the first time you guys are seeing this, they're going to want the second answer. But I'm more concerned about, like, do you guys know the format? The first line shows me you get the format, so that's why I kind of like the first line. Do you guys have questions on that one? Okay, next one. What operation are we being asked to do? Division. Do we have a number we're going to plug in?
No.
No, we know that because it's just an x right here. Just like there was an x right there, no number to plug in. So k goes on top, h goes on the bottom. Yep. You guys have learned a lot this year. Before winter break, we did like a week of questions like this. When you have plus or minus signs, can you just start like canceling things out? No. The bottom, what process do we have to do to the bottom? You have to break it down, you have to factor it. X squared comes from x and x. How do you get a minus 25 with nothing in the middle?
Plus and minus 5.
Yeah. So if you have plus or minus signs in your fraction, it does need to be factored first. Once it's factored, if it's the exact same, they cancel. So we still have x minus 5 on the bottom. If we're ever missing part of our fraction, what number goes there? A 1. So division, you just put them in the order top, bottom, and you reduce. If you have a plus or minus sign, make sure you do factoring first before you reduce it. Questions on division? Okay, next one. Put a star next to this one. This is another composition. So there's two ways to write compositions. The first way is with the parentheses. The second way is with this open circle. So this is m of g of x. That open circle does not mean multiply. It means m composed with g. The order is the same though. So like this is the same as saying m of g of x. Like these two are equivalent, which is nice because you don't really need to know like how do I write it in the other form. You just need to know which equation is first. So m is given to us first. In both forms, m is first. So that's our skeleton equation. That's our main one. If you look up to the top, what is m's equation? 2 root x. And the only thing you're going to do differently, instead of an x, what are you going to put in its place to begin with? To begin with. To begin with. M's equation is 2 root whatever you're being told to plug in. Do it in 2 steps. Don't try to plug it in the first step. Just first write that equation. X is a variable. It's your plug-in spot. So wherever you see an x, just put a big old set of parentheses. And then go back and realize, hey, what am I being told to put in those parentheses? G. And what does G equal?
35.
Yeah. This is not going to simplify to anything nice, so we're not going to worry about simplifying that. So again, you always start with your first equation. To begin with, put big old set of parentheses whenever you see an x. After you have that skeleton there, then you go back and fill in that blank. Okay, next one. Composition. We know it's a composition because the f and the k are separated by a parenthesis. What is the first equation we're given? The f. So this is where we start. So f's equation is 3x squared plus 2. So that 3x squared literally means 3. And instead of an x, what are we going to put? Parentheses squared plus 2. So whichever one is given to you first, that's what you write first. Instead of an x, put parentheses. Then you go back. What are we being told to put in those parentheses? Okay, and what does k equal? What's k's equation?
X plus 5. There's also an X.
Now the difference here, there's not an x at the end, there's a 2. So what do you think we're going to do with that 2?
The X is
Plug it in. So it's kind of nice. It's consistent throughout. If you have a number in those parentheses, you're always just going to plug it in. Whenever you're plugging in, I would just plug in right away because it's easier to compute with numbers and with variables. Orders of operations. What is 2 plus 5 squared?
49.
Good. So we have 3 times 49 plus 2. What is 3 times 49? Plus 2? Yeah, 149. So regardless of what operation you're being asked to solve, if there's an x in that parenthesis, you just leave it be. If there's a number, you plug it in. Do you guys have questions? So Thursday's assignment was the, oh yeah. Because these are just doing like adding two things together. There's no way to like undo that adding and go back and check
So
it.
we can check.
Okay. That's only solving equations. You can really check. Okay. This is the tan sheet. So the only difference between this and what Thursday was is Thursday also had a story problem. That story problem was about like coupons and discounts. It's pretty much identical to the one that's in the notes. So Thursday, operations with compositions.
I understand a lot.
Flip to the back side. Friday was on inverses. So inverse to me, I really like this lesson because it really is just a thing of like, do you know the definition? Because I will never forget my senior year of high school sitting in calc and the teacher asked us like, what's an inverse? And someone said it's when you flip a fraction. But what is it called when you flip a fraction? A reciprocal, not an inverse. So they're two different things. So an inverse instead, what does it mean if something is an inverse?
Flip. You gotta flip
Switch.
the X and Y.
You switch your x and your y. That's all an inverse is. So in math, an inverse happens when your x and your y switch. Every relation on x and y switches, everything switches. So if you're trying to find an inverse equation, y equals negative 7x or negative 2x plus 7, you literally switch your x and your y. That right there is the inverse. As soon as you switch your x and your y, you have found the inverse. But do we ever really work with equations that are set equal to x? No. So after you switch your x and your y, we solve for y. And that's just because we're used to working with equations solved for y, so we just get it into a form that's familiar for us. If I want to get that y by itself, what do I have to move over first? How do you move a plus 7? Minus it. How do you undo that negative 2? When we divide by negative 2, is x and negative 2 evenly going to divide?
No.
Is 7 and 2 going to divide?
No.
No. So if you leave it as a fraction, I'm okay with that. If you split it, that's fine. If you leave it, that's fine. I think on my answer key, it's like a weird mixture of both. Doesn't matter what form you leave it in. This is the inverse. So inverse equation just means your x and your y have switched. You solve for y. The equations should be like familiar to each other, but they're probably not going to be the same. So these ones are both linear. Questions on that one? Okay, next one. To make it easy on ourselves, what's g of x the same as?
Y.
Y. I like to rewrite them so they're always set equal to y, because it'll just cement in your brain that an inverse happens when your x and your y switch. So even if it's given to you in function notation, you can just say it's y equals, because then you switch your x and your y. And then we just got to get y by itself. For this one, do we have to undo the square root or the 9 first? Square root. How do you undo a square root? square both sides. Last step to get y by itself. Yeah, you minus your 9. So inverse just means your x and your y have switched. We then solve it for y just because that's kind of what we're used to looking at. Couple things. The reason that inverse comes up in this unit specifically is because we've been working with radicals and exponents. They're inverses of each other. They undo each other, so they're also inverse equations. The other reason it comes up in this unit is because it's kind of like a precursor to something we're going to do in our next unit. So just know the idea of an inverse doesn't go away. One last thing with this. If we want to be like super perfect with our answer, if this equation is called g of x, instead of calling the inverse y, what could we call it? Not g of x. G to the negative 1 of x. So notationally, I'm fine with either of these. The reason you would want to put it as the second one is then, like, if you wrote the y equals, technically you should label it as like, this is the inverse. But if I tell you g and you give me g to the negative 1, that's you saying it's the inverse. So like ACT wise, they're going to have it written this way just because that's the right notation. They mean the same thing though. Yeah. Why do we what? How did I reduce? We can't. If we take a square root, we're doing a new operation that's going to change it. So we're just getting y by itself. So we're not solving anything. We're just like setting something up essentially for graphing or whatever. Okay, last one. This is like the backside of your homework where you're given an equation and we want to find the inverse and graph both of them. Let's start by just graphing our first function. We haven't graphed anything like this in a while, but it's a parabola. That plus 4, where is it going to move our graph to? Is it in parentheses or at the end by itself?
It's at the end by itself.
It's at the end, so it's going to go up 4. And then since it's a negative x squared, is this graph going to go up or down?
Down.
Down. So instead of going over 1, up 1, now it's going to go over 1, down 1. Both sides, x squared goes on both sides. We go back to the beginning. Now when we go over 2, how much do we go down? 4. We go over 3, how much do we go down? 9. So x squared is the same parabola you guys have been graphing forever, where your pattern is that 1, 1, 2, 4, 3, 9. So x squared, 1 squared is 1, 2 squared is 4, 3 squared is 9. Now let's find its inverse. So if we want to make things a little bit easier on ourselves, instead of calling it f of x, what should we call it? Y. All an inverse means is what happens to that x and y. They switch. That's your inverse. Now what variable do we get by itself?
We're gonna get the
Y, just because we're used to having y's by itself. What has to move over first?
The 4 got a minus.
We have to get the y squared completely by itself, so what's the next thing we have to undo? The negative. It's really a negative 1, so how do we undo that negative 1? And then this is different than the first one on this page, because what's x divided by negative 1? What's negative 4 divided by negative 1? So, since it actually like turns into not bad numbers, you can actually do the division. That 2 didn't evenly divide the x and the 7, so that's why I just left it as a fraction. Last step, how do we undo y squared? And then here's like a weird catch that we haven't had in a while. We just took a square root, so what has to go in front of it? Plus and minus. Square roots happen when you introduce a square root. We've been given square roots most of this time, but here we have to do it ourselves. If we want to be super perfect, instead of calling this y, what can we call it? F to the negative 1 of x, but your answer is the same thing. So these two equations, they mean the same thing. Using that little -1, it's just really easy to be like, oh, this is the inverse of f, the one above it was the inverse of g, it kind of just like follows the mean. Now there's a couple tricks to graphing these. If this was an equation that you know how to graph, you can just graph it. Like if it was linear, find your slope, find your y-intercept, put on your graph. This is a little bit different because when we graphed square root functions last week, was there that plus minus sign in front? No, we just did the one side of it. So there's a trick that you can use to graph inverses if you're not exactly sure how to graph it. Like we haven't done plus minus graphs. And it has to deal with if I can make a table of values. So this graph right here, it's just a whole bunch of ordered pairs. So like this ordered pair right here is back 3, down 5. The next ordered pair, what's the ordered pair right there? What's its x value? -2, what's its y value? 0. What's the ordered pair of this point? X value? -1, 3. What's the top ordered pair?
0.
And then what's the one next to it? 1, 3. Next one? 2, 0. Last one? 3, -5. So the reason that this trick is going to help us, we have the original graph, we have the original table. So if this is the graph table's original, what do we do to this table to get the inverse of it?
Switch it.
Switch your x and y. So if you're not sure how to graph it, you can just take that table and you literally just switch your x and y. So now it's -5, -3. Switch your x and y. 0, -2. Because all an inverse means is your x and y have switched. Everything about it switches. So if you are not sure how to graph it, again, because of that plus minus right there, we haven't graphed things with plus minuses. It's a -x on the inside. It's a goofy graph. Instead, just write the table of the original one, because then when you switch it, those are your new ordered pairs. So -5, -3, left 5, down 3. 0, -2, 3, -1, 4, 0. 3, +1, 0, +2, -5, +3. So all we did is that table, it's the x and the y. You already switched your table, so -5, -3 means go back 5, down 3. When you connect it, what happened to our graph? Yeah, it turned. So an inverse is a reflection over a diagonal line. So when you graph this, it should look similar, but it should just kind of be like turned a little bit or rotated, reflected. On the green sheet, it asks you about if things are functions. A function means each x gives you one answer. So every time you plug an x value in, you should get the same answer every time. Is the inverse of this a function? No. And the easiest way to tell, like the first time we plugged in a 3, what was our answer? -1. The next time we plugged in a 3, what was it?
1.
+1. If you draw a line through the graph, it hits it more than one time. So the function ones are on there kind of just to remind yourself of like, what is a function? It just means if you draw a line through the graph, it can only hit it one time. Do you guys have any questions on the inverse? Okay.